Hello, Applied Physics students. This is Mrs. Kremschreiner, and I'm going to go over the speed machine cube. It is not necessary for you to glue this all together and cut it all out and that sort of thing. That is not necessary. Okay. However, I would like you to take a picture of it or whatever when you're finished and turn it in. Okay. So this first one says, NASCAR driver Jeff Gordon has a car that is one of the fastest on the circuit. If it travels 600 miles in 4 hours, what is his cruising speed? So our equation for speed, remember, is speed is our change in distance over our change in time. Okay. So 600 miles, that's our change in distance. And 4 hours, that's our change in time. So using this equation and plugging in our numbers, we're going to put 600 miles divided by 4 hours. On your calculator, you're going to do 600 divided by 4, which gives you 150 miles per hour. The fastest car on Earth, an English-made Thrust SSC, would win every NASCAR race in America. If it takes 0.5 hours, 30 minutes to travel 380 miles, what is its speed? So again, our equation that we're using is speed is our change in distance over our change in time. Again, half an hour, that's our change in time. 380 miles, that's our change in distance. So 380 miles divided by 0.5 hours. So we do 380 divided by 0.5 gives us 760 miles per hour. The Spirit of Australia, a hydroplane boat, made speed records by traveling 239 miles in 0.75 hours, 45 minutes. What is its record-breaking speed? So again, the equation we're using is speed equals the change in distance over the change in time. Again, 0.75 hours, that's our change in time. The 239 miles, that's our change in distance. So 239 miles divided by 0.75 hours. So I take 239 and divide it by 0.75, and I get 318.6 repeating miles per hour. Make sure you're including your units because, again, a number in a science class without units doesn't make a whole lot of sense. The fastest train on Earth, the TGV from France, can travel at faster speeds than trains in the United States. During a speed test, the train traveled 800 miles in 2.5 hours. What is its speed? So again, our equation is, our speed is our change in distance divided by our change in time. Again, 800 miles, that's our change in distance. 2.5 hours, that's our change in time. So we're going to plug in 800 miles divided by 2.5 hours. On your calculator, you're going to take 800 and divide it by 2.5. Okay? And you should get 320 miles per hour. The fastest plane ever made, the Lockheed SR-71, was able to travel 220 miles per hour. Based on the speed, how far could it travel in 2 hours? So this is a little bit different one, right? Because this is giving us we want to know how far. They give us the change in time, and they tell me my speed. So remember, on the notes that you took, we did the manipulation for this. How far is our delta t? So our equation for delta t is speed times our change in time. So our speed is 220 miles per hour. No, sorry, 2,200 miles per hour. Times 2 hours. Notice our hours are going to cross out. So we do 2,200 times 2, which is, 4,400 miles. So it would go 4,400 miles in the 2-hour time frame. So now we have done all these calculations. It says, out of all the machines on the cube, which one is the fastest? So if we kind of go back and take a look at that, right? The NASCAR was 150 miles per hour. The thrust car was 760 miles per hour. The boat was 318.6 repeating miles per hour. The TGV, the train, was 320 miles per hour. And the plane was 2,200 miles per hour. So obviously here, right, the plane is the fastest. So it's first. Next is the thrust. Then it's the train. Then the boat. Then the NASCAR. So again, all you need to turn in for this is your showing your work, similar to how I did my work on these. So I'd like to see an equation each time, plugging in numbers and units, your answer with the correct units, okay, like I did each time on here. And just take a picture of that and turn it in for the assignment. Have a great day. Talk to you tomorrow.